Every coastline is a silent stage, performing a dance you never truly see. It's a performance unfolding right now, a gravitational ballet orchestrated by cosmic forces, pulling billions of tons of water across our planet. We call it the tide, but it's so much more than just water rising and falling. It's a fundamental rhythm of Earth, shaping ecosystems, influencing weather, and even dictating human history. Most of us understand the moon plays a role in this, but the actual mechanics are far more intricate than a simple pull. It's a complex gravitational conversation between three celestial bodies: our Earth, its steadfast companion the moon, and the distant, yet dominant sun. For centuries, the tides were a profound mystery, observed but not understood. Ancient civilizations, from the Greeks to the Polynesians, charted their movements, creating calendars and navigation systems. They knew the moon was key, but the how remained elusive, a whispered secret of the cosmos. It took a giant of science, Isaac Newton, to finally crack the code. In his monumental work, Principia Mathematica, published in 1687, he laid out his law of universal gravitation. This wasn't just about apples falling from trees. It was about the fundamental force governing everything, from planets to particles. Newton's insight was revolutionary. He proposed that every particle in the universe attracts every other particle with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Sounds a bit academic, right? But it's the key to everything. Now let's bring it back to our silent symphony. Imagine the Earth and the moon. The moon's gravity pulls on the Earth, but it doesn't pull uniformly across our entire planet. It's a differential force, meaning its strength varies depending on how close a part of Earth is to the moon. The side of Earth closest to the moon experiences the strongest pull. This tug essentially stretches the water on that side, creating a bulge. Think of it like a cosmic hand gently kneading a ball of dough, pulling the surface upwards. But here's the surprising part, the one that often trips people up. There's also a bulge on the opposite side of Earth. Why? Because the Earth itself is being pulled towards the moon, leaving the water on the far side to lag behind, creating another bulge. So at any given moment, there are two high tides on Earth, roughly on opposite sides. And as Earth rotates through these bulges, we experience the familiar rhythm of two high tides and two low tides each day. This is the moon's primary influence, but the moon isn't alone in this cosmic dance. Our own star, the sun, though much further away, is also a gravitational powerhouse. While its tidal effect is less than half that of the moon, it's still significant, adding another layer of complexity. When the sun, Earth, and moon align either at a new moon or a full moon, their gravitational pulls combine, creating extra strong tides. These are known as spring tides, not because of the season, but from the Old English word springen, meaning to spring forth or surge. Conversely, when the sun and moon are at right angles to each other relative to Earth during the first and third quarter moons, their gravitational pulls work against each other. This results in weaker tides, known as neap tides. This interplay between the moon and sun creates a predictable, yet constantly varying tidal pattern. It's why tide charts exist, predicting the exact ebb and flow for any given location, crucial for shipping, fishing, and coastal communities worldwide. But the story doesn't end there. Our continents, the shape of our ocean basins, and even the Coriolis affect the force created by Earth's rotation all play a part in modifying these fundamental tidal forces, making local tides incredibly diverse. Take the Bay of Fundy in Canada, for example. It boasts the highest tides in the world, with differences of up to 50 feet. This isn't just because of the moon and sun. It's due to the unique funnel shape of the bay, amplifying the tidal surge. Or consider the Mediterranean Sea, where tides are famously small, sometimes just a few inches. Its narrow opening to the Atlantic restricts the movement of water, dampening the powerful oceanic tides that affect other parts of the world. The moon's gravitational embrace even slows down Earth's rotation. Over billions of years, this has gradually lengthened our days. Think about that. The same force that pulls the tides is subtly altering the very duration of our existence. And it's a two-way street. Earth's gravity is also affecting the moon. Our planet's pull is slowly, almost imperceptibly, pushing the moon further away. Each year, the moon drifts about 1.5 inches further into space. This means that billions of years from now, total solar eclipses, where the moon perfectly covers the sun, will no longer be possible. The moon will appear too small in the sky to completely block out our star. A cosmic ballet with an inevitable slow-motion ending. The tides are more than just a phenomenon. They are a living demonstration of universal laws. They connect us directly to the cosmos, showing us how the distant dance of celestial bodies impacts our daily lives, from the rhythm of the ocean to the length of our days. Next time you stand by the ocean, watching the water rise and fall, remember the silent symphony playing out before you. It's a testament to the elegant, powerful forces that shape our world, a constant reminder of our place in a much larger, interconnected universe. It's a beautiful, intricate system, humbling in its scale, yet profoundly personal in its impact. The moon, the sun, and earth locked in an eternal, gravitational embrace, orchestrating the ebb and flow that defines our blue planet. What other hidden forces silently shape our world?